This is Python Toolkit for beginners. I'd like to show you a way to automate data transfer between Pipesim and Excel. In this example, Excel won't contain any control elements and will be used as a data storage only. For this example, I use the case study model CSN301. So I opened this model and saved it to the temporary folder. Let's check the model. This is the simple network with one source, one well, and two sinks. If we click on Network Simulation task, we can see that the boundary conditions are already defined. I'm going to use them as is without any change. So we have the pressure for the well and for the sinks. And for the source, the gas flow rate is defined. You may see that this model contains the choke. And I'd like to know how the choke size affects to the pressure distribution in the network and of course the liquid and gas production. So what I'd like to do is to run network sensitivity where choke size is used as a sensitivity variable. For this purpose I created Excel file with table. In this table I have the input column where bin size is used as input, and I've already predefined several variables, and several output columns. So for each bin size, I'd like to report liquid rate and gas rate from the well, calculated pressure from the source, and then of course gas rate from one sink and liquid rate from another sink. So to solve this task, I need to establish the connection with Excel from Python code, read data, update model, run Pipesim simulation, and report results back to Excel. Let's start from the code and establishing the connection. To establish the connection, I need to import some library which works with Excel. So I can do it using the import, then call Excel Links and use it as XV. Excel Links helps me to establish the connection with Excel file. I will use the XV, then call the book, and as argument I need to pass the name of my file. So I will use the temp, my book Excel6. This is the path of my file, and I will save it as Excel variable. Now I've got a connection to the file itself, but my file might contain several pages. In this example I have only one, but anyway. So I need to get information from this page. For this purpose I will use Excel sheets and then just specify the sheet name and save it as a data sheet. Now I get access to my sheet. If I want to read information, I can use data sheet, and then for instance I can use the method range and specify the name of the range. Let's see. In this table we have something, for instance in the B4 range we have the text input. So let me use B4, and if I just apply right now this code, I will get this output. It happens because I've got the object itself, but from the object I need to get the value. So for value I need to use the method value, the property value. What else we can extract from this object? Instead of the property value we can extract, for instance, the row number, or we can extract the column number. There is another way to work with cells in Excel. Instead of the range method, I can use the cells, and I need to pass the row number, for instance 2, and then the column number, for instance 1. And I want to get the value, and output is empty because in the row 2 and column 1 there is no value. But I will write something instead of the reading, and I will pass, for instance, some text, and we can see that the text is updated in this page. Instead of the text I can send digits, the digits are there, or I even can send some list. And you will see that the results is very interesting because Excel Links automatically split this list and assign to the next cells. And we can do all different things here. You can find information how to work with Excel Links in the separate site, but I'd like to show you what else we can do with update. If I want to erase, I will send the none, and then the value from A to is reset. So now we are ready to read information in the cycle. For this purpose, I need to know what's the first cell and then just read them one by one, following down. So in my case, the first cell is B8, and I need to start from it. But in case I add something in the left, like insert any column or on the top, I need to change all my code to update the cell position. Of course, it's not convenient, and to avoid it, I'd like to use the named range. For instance, I have this range B5, which is called choke. And if you want to set up the name for other ranges, you can use the name manager on the formulas tab. And here you can find all the details about the named range. But in my case, only one is enough. So I know that 3 rows below from this named range, I have the first input for my choke. And each next column contains the data for the output. And if I add some row below table or from the left side, insert the column, everything will be recalculated automatically and all my code will have a reference to this named range only. So let me show you how it works. So I will use the data sheet, then range, and just call it choke, and read the value. And we can see that the value is choke. So everything can be calculated from this position. So let me extract the value from this choke. This is the row, and I will save it as a row. And the same I can do for the column. I will copy it here and column. And if I want to go in the cycle and read the values one by one, so first of all I need to start not from this row but the 3 rows below. So I will change it and add the increment 3, and then I will do the cycle while datasheet range. So the range I will use the cells because I will pass explicitly the row number and the column value, and I will check the value. And while I have some value, it means that I have the input data. I will get this information. So I will save it as a bin size, use the same row and column to read the value, and then I would like to print information, say that print choke size is, and then I will use the bin size. And then of course I need to add the increment to my row, otherwise I will end up with infinite loop. So I will add row +1 and run the simulation. And we see that we started from the row and then found the first position, 6, and then went through all of them up to the last position in my table. So from 6 up to 0.5. Okay, that's all what we need to know how to run through these values in the cycle. But I'd like to change the increment right now because I want to develop some code and I would like to run my model. I don't want to spend more time waiting while all the simulation are finished. It's enough for me just to run one simulation, and once I'm done with all simulation, I just change the value back to 1 and will check all my code with running through all these values. But right now I will set the 10, and that's enough for me to work only with first row in my table. And now I need to pass this to the model. Before I do it, I first would like to define, to be honest, the output variables. So for my table, I need to report the liquid rate, gas rate, pressure. So I will define sensitivity variables, and I will say the system variables, stock tank. Now I will use the volume, flow rate, gas stock tank, and then I will use, instead of the gas, I also will do the oil, what else, liquid, and I also need to define the pressure. So these will be the list of my variables. And I also would like to add one more function to report some results. So I will get the result object with a lot of things inside, and I need to extract the value, but I don't want to go into details right now and just create the fate function, get results. And for this function, I will report just something like 1 to 3. That's enough for me. And let's imagine that we are going through this, and we are on the cycle. We read the bin size. Now we need to update this bin size, so we will use the model set value. I need to know the component name, and if we go back to our Pipesim model, we can see that the name of the object is choke. So I will use the choke. Then I need to start the parameter I want to update. For the choke, it will be choke, and that the name is bin size, and bin size is the variable. So the value should be updated here, and I need to run the simulation. So everything will be saved as a results, and then I will run model, tasks, network simulation, run, and I'm not going to define any details here, just want to say that profile variables will be empty. I don't need to report them, it will speed up my simulation. And for system variables, I need to report just few. I already predefined them, it will be the system variables. And the results will be reported here. Before I run the simulation, it's nice to report something in the cycle, because we run it in the cycle, what's going on. So I will just copy this content and call that run net simulation with bin size, and then just inches. And what's the value of my bin size? It's here. So this is my bin size. We will report that code, and then we need to report the results. And we just call it print, not print. We can use the data sheet, and then we need to use the cell. And we have the row, because for each row we run the simulation, but we also need to specify the column. And if you remember, the column means this column. And if I want to report something for the well, I need to do the column +1. So for each row, for instance, for this row, I read the information from the row 8. I report the information for the row 8, but I use column 2 and report for the column 3. So I will say the column +1 value, and imagine that I've already parsed the results from there. I'll get results and add them here. So now I'm ready to run the simulation. So we can see this output, run net simulation with bin size 6 inches, and the results should be reported. That's correct. I've done this mistake, so it should be cells. And run it again. Okay, now we can check. We have the output here, 1, 2, 3. That's fine. And we have the results output. Let's check it separately. In the results output, we have the node. In the node, we have different parameters. I need to report some of them. For instance, we have the list of the values. First of all, we need for the well to report the liquid rate. So I will take the liquid rate and add it there as the first argument. And now I have this output for liquid rate. I have several components, and we need to report the liquid rate for the well. So I will use the well. Okay, so we can do the same to report the output, but it will be a really big construction, but we can do it, yeah. So let's check it. For instance, for well 1, we report the well. Then we can do the same to report the second parameter. For column 2, I can report not liquid rate, what's needed for my table. The gas rate should be there. So instead of the liquid, I will report the gas. And then for the next one, I need to report, for 3, I need to report the output pressure for my source. And then I need to report for the next one column for gas sales. Do the gas sales. And I need to report the gas stock tank. And the last one, column 5, I need to report for oil facility. facility, I need to report the oil stock tank. So I'm ready to run the simulation. Let's do it one more time. Okay, the simulation is finished. Here we can see that the values are reported here. And now we are ready to change this increment and to run everything from scratch, but do it one by one. So for each of these input, like for this number 6, the choke pin size will be updated and network is calculated and the output results are reported there. And then we goes to the next line and report them here, and then goes to the next line and report them one by one. While it's going there, I'd like to pay attention to one thing. You need to be careful with reporting this way, what I've done, because I didn't care about the results. In case some wells or some objects are not existing in the results, your code will be crashed. So you need to create some clever method. For instance, this gets results. You can use the row. You can use, for instance, parameter name. So we can pass the results here and call the parameter and maybe component and do the check if parameter in results. Then we need to check another one if component in results parameter, and only then report results parameter and component. Otherwise, we just need to return none. This method will be much safer because you check on each step, you check if the parameter exists in this element, and so that we use the node here, of course. So we need to, if we pass the results, we need to use the node there. Node, that should be node, and here we need to use the node. But anyway, so we check on each step, we check if the parameter exists, and if the parameter exists, then we check if the component exists, and if everything is in place, we can report the value. Otherwise, we just report none, and it helps our code to continue working without any crash. In case some variables are not calculated or some well doesn't work anymore. So we've got the all output here, and now it's the time to close the session. As usual, we need to call the model close to close connection with the model. And since we are working with Excel, we need to close the connection with Excel as well. There are many different ways, but I prefer to do the following. So I do the XV, book, and then up, and then do the quit. And the Excel file will be closed automatically. That's all. Thank you for your attention.